Good morning, dear students. This is D. Hanumantu, Assistant Professor. Today, our topic is about fiber types of fibers in the fiber optics and laser instrumentation. So, anyhow, once again, recall uh, the topics which are covered in the last class, right? So, what is fiber? What is fiber? Fiber is a waveguide. Fiber is a optical fiber is a head-thin cylindrical fiber of glass or any transparent dielectric medium. Sometimes not only glass, maybe plastic also. So it is very head-thin. The diameter of the fiber is less than 8 thin or almost equal to 8 thin. You understand how much the size of the optical fiber, right? And maybe this optical fiber may be useful for communication purpose in the electronics and communication engineering. And so this optical, the specialty of this fiber is it guides the light, it guides the visible and infrared light over long distance, Today we are enjoying the phone calls or any other other you know other things, right? So this is with the help of optical fiber communication. These are all done with this optical fiber cables, right? So the importance of this optical fiber is not only everywhere, anywhere, this is optical fibers are very much useful. Not only communication side, but because you are all instrumentation people, the instrumentation side also, these optical fibers are very much useful. For example, if you take endoscopy, in the endoscopy, suppose if any person is suffering with stomach pain or any other stomach problems, so taking the optical fiber at one corner through that pipe, you are sending to the intestine so that we can identify the problem within the stomach intestine, right? So anyway, not only for biological purpose, maybe medicine side or industries, in any industries. For example, we are all concerned distributors people, for measuring for measuring for measuring any distance between two instruments or moving of the instruments, accelerations, velocities, any pressures, force, temperature. So all these parameters uh, uh, you can you can measure easily with the help of this optical fiber concept. Right? See, once again recall the structure. The structure of the optical fiber is like this. So first of all, there is a core. This is called core. Blue color is core, surrounded by another material that is called cladding. This is called cladding, and surrounded by other material that is called covering. That is also called outer jacket. Outer jacket. You know how we are going to make this core and cladding. This core is made with material combinations, maybe plastic or maybe glass, or maybe the two combinations. Like this cladding also the same compositions, maybe different compositions you can also take, because there is one condition here: refractive index of the core and refractive index of the cladding may not be equal. May not equal. So actually, how should the refractive index of the core means? Refractive index of the core should be high than refractive index of the cladding. So you select the material composition such that for design of optical fiber, such that by satisfying this condition, refractive index of the core should be very high than this cladding. We can represent the core refractive index is small letter N1 and refractive index of the cladding is small n2, such that N1 should be greater than N2. N1 should be greater than N2. Next, next slide. Yeah, you know characteristics all are already these are discussed. Next one, next slide. Okay, yeah, yeah. This is important. So recall once again how this fiber will guide the light throughout this long haul distance of the medium means there is a basic principle is available. The basic principle of the optical fiber is total internal reflection. Total internal reflection means if any light, show this. Show me other slide. Other slide. Next, yeah, yeah. See this. This is say this is a water. This is air. Water. This is air. See when light rays will light any light ray will fall on the at one point will fall on at one point. There are two possibilities. Any light ray will fall on the surface. There are two possibilities. One possibility is the light ray may be refracted and బయటకు వెళ్ళిపోవచ్చు. The light ray may be reflected. తిరిగి అదే surface కి రావచ్చు. There are two possibilities. The light ray may be refracted or the light ray may be reflected back. The optical fiber will function on second option. Second option means whatever the light ray will fall on the surface, the same light ray will be reflected back. Reflected back. Right? So that optical fiber communication system is going on the basic principle of total internal reflection. So this can be done by selecting proper core and cladding. You select the core and cladding such that refractive index of the core should be high than the cladding. So when you select this combination, no doubt you can follow the total internal reflection. When the light is entered at an angle θ1, the total light will be reflected back to the angle θ2. See this diagram. If you imagine this is the optical fiber, and the color, the blue color and red color are the light signals. Say they are called the light signals. Light signal 1 and light signal 2. When the light signal 1 will fall on this point, that is reflected back like this, and again reflected back like this. So the light is reflected in zigzag manner within the core of the fiber. There is a small difference between core and fiber. Core means the 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 medium through which the light is going to be propagating. Through which the light is going to be propagated. Core. But what is cladding? Cladding is a supporting to the core. If light is propagating to the core, that is called communication. If the light is propagating enter into the cladding, that is called loss. Optical fiber means combination of core and cladding. But don't think that light is propagating through the cladding. If light is propagated through the cladding, that is called loss, transmission loss. So as an instrumentation engineer, you select the optical fiber such that core should have some refractive index and cladding has other refractive index. Then the light is simply propagating through the core only, strictly speaking, and through the core only. And fiber means combination of core and cladding. Optical cable means core, cladding, and outer jacket. It is called cable. Cable is different from fiber. Remember, fiber means rightly we have to think that it is a core. Followed by cladding. So the light when it enters into the core, through the core only the light is going to propagate with the help of the principle of total internal reflection. Right. Next slide. Yeah, see that classification of optical fibers. Already it is covered, but I need to add some other points into this. So optical fiber very much very much useful as a medium in the optical fiber communications, because all the communications today, all the communications are today uh, um, majority is done by these optical cables. Optical cables. Maybe these optical fibers may be useful not only communication. Just now I said that it is maybe useful for industries in the medical side, medicine sides also, right? And see, these optical fibers may be classified like this: single mode fibers and multi mode fibers. Single mode fibers means, mode means what? What is mode? Mode means the path, direction, one path or one direction. When the light enters into the fiber allows only one path. The fiber allows only one direction of propagation of the light throughout the medium, throughout the cable. That is called single mode fiber. Single mode means single path. The light may take single path to propagate throughout the medium. Multi-mode means see, understand, it is a light source. Light source. The light source means here maybe LED or maybe laser. For example, LED will emit some light. Laser also will emit some. LED will emit some light, or laser also emit some light. Whatever the light is emitted, that is coupled to optical fiber. When it is coupled to optical fiber, the same light will propagate throughout the fiber. Remember, when the light is coupled to the fiber, that light may take a single path throughout the fiber for propagation. Throughout the fiber for propagation. That is called single mode. Only one mode. One path is available. One path is available. Next, multi-mode. Multi-mode means, yeah, go for the previous slide. Multi-mode means, yeah, multi-mode means, see, the light is emitted, maybe with the help of LED or laser. When the light is emitted, that is coupled to the fiber. When the light is coupled to the fiber, the light may take not single path. It may take multiple paths. Multiple paths. See, like this. This is one path, this is another path, this is another path. We are showing a diagram, three paths, three directions. Remember, when the light takes any direction, remember, it should follow total internal reflection principle. No other principle. The light may take a single path, it should follow total reflection. When the light follow 3 or 4 modes paths within the fiber, it should follow the basic principle of total internal reflection. No other principle is available. If it is not following that principle, it's not a communication. It's not optical fiber communication. Remember. So it may be single mode or it may be multi mode. The light should follow the basic principle. Path means here mode. Mode means path. Number of modes. Number of paths available. The light may take. Maybe there may be some disadvantage in the multi mode. We will see later. What the disadvantage? Already we discussed. I think so. What is it? Group delay. Group delay. Group delay is also called pulse fading. Pulse fading. See, when the light may take three paths, any path one may be delayed at the end. Sometimes path 2 may be delayed at the end. Path 3 also delayed at the end. At the end. So, if your light may take 6 to 7 paths, say for example, all the light rays may be delayed at the end. All the 6 rays may not be equal in the velocities, may not be equal in the group velocities, different in group velocities. When the velocity is different, the light signal at the end may not be received at a time. So it looks like pulse spreading. Pulse is going to be spread. The light may be superimposition. That's also called overlapping. Lights are overlapping. When the lights are overlapping, whatever we are sending as an input, we cannot exactly receive at the end, at the output. We cannot receive. That is called loss. It is also called pulse spreading. Pulse spreading. Pulse spreading means pulse spreading means overlapping of the light signal. Overlapping. We are not expecting overlapping signals at the end. We are sending light signal as a pulse. The same light we are expecting at the end. Expecting at the end. If you are not expecting the same width of pulse at the end, that is called pulse spreading. It is also called pulse broadening. Pulse broadening. It is a loss. It is a loss. So the main disadvantage with the multimode fibers are pulse spreading, group delay problems, pulse broadening problems. Simply, there is a loss in the signals, light signals, mixing of the light signals. So the multimode fibers may be useful for some other purpose, but single mode fibers may be useful for other purposes. So you select the optical fibers in such a way that which fiber is suitable for our purpose. Optical fibers in the medicine, or optical uh, fibers in the endoscopies. We try to prefer single mode fibers. Optical fibers in the communications, for example, long haul communications or other point to point links, you select a simple multimode fiber because we are not expecting that much of accuracy there. So accordingly, you select the types of fibers whichever you want. So this is what single mode and multi-mode fibers. And here we have other types of fibers. So broadly speaking, single mode and multi-mode fibers, two classes. But if you classify again single mode and multi-mode fibers, they are nothing but you go for next slide. Next slide. Yes. On the basics of refractive index. Refractive index. See, you know only two types of fibers. Two types of fibers. Single mode fiber and multi-mode fiber. You know only two. But actually, if you go for single mode fiber and if you go for multi-mode fiber, there are, based on the refractive index, again we are going to classify. Roughly, one more is step index fiber, other one is graded index fiber. What is step index fiber? Step index fiber means so this is the step index fiber means, see, if you take, this is called optical fiber. See that the fiber, this is called optical fiber. This is the first end and this is the second end. If you want long haul distance, join other fiber to this fiber one. If you want one more long haul purpose, join the third fiber. Generally, from one end to second end, the maximum fiber length is 1 kilometer. 1 kilometer. How many fibers we need for 50 kilometers long haul distance link? Definitely we need 50 fibers, 50 optical cables. 50 optical cables. So from here to Hyderabad, say for example, if you have hardly 400 kilometers, say for example, 500 kilometers. So we need 500 cables for making optical communication link. 500 cables we need. My point is, To take one optical cable, and see the first corner, first end. If you see first end, the surface is whether it is step index or grade index. Uh, we can identify based on the refractive index. Based on the refractive index. How do you identify means? If it is step index, the refractive index of the core is constant. Refractive index of the core is constant throughout the surface. Throughout the surface. That is the meaning of step index. But grade index means C. Is called grade index. Grade index. The refractive index, dear students, understand the meaning of step index? Understand? Anyone respond please? Lokesh, Kishore, Vinutna, Sushma, Sandeep, Manavi, Venkateswamy. Understand the meaning of step index? What is step index? Step index means the refractive index of the core is constant throughout. But in this, grade index means the refractive index of the core is not constant. See that this is called core, this is the clay. The core refractive index is not constant. It is varying. It is varying. So this is the meaning of this. This is the meaning of grade index. Grade index. We are representing step index and grade index by this. See this diagram. See this diagram. Refractive index, step index optical fiber represented by a solid lines like this. Sharp solid lines like this, zigzag manner. But the light within the fiber of grade index fiber is represented like this, smooth curves, smooth curves, smooth curves. Right? We are differentiating like this. What is the meaning of this? Step index means the refractive index of the core is constant. Grade index means refractive index of the core is not constant. Okay? That is the meaning of this. Single mode, as we discussed that, single mode means these are refractive index profile. These are called profiles, refractive index profile. See the step index, step shape. Grade index, smooth curve. And single mode, it is almost equal to step shape, but size is different. The radius is different. Single mode and step index comes under one category. This grade index is other category. See this diagram here. We know that complete information regarding the step and grade index optical fiber. Next slide. Next slide, ma. Okay, these are discussed already, losses and optical fiber. Next. Okay, these are discussed. Next. Okay, next. Right. Okay, these are discussed. Disadvantage. Okay, all are being discussed in the last class. Okay, next we go for second one. You know, for this first chapter, so we have to uh, you have to focus on transmission losses. It is important, transmission losses. There, what are the ways the optical light signal is going to be lost when the light is propagating through the fiber? So there are number of chances are available for getting loss of the light signal. Right? Show me the Vinodna, show me the second slide, second chapter slide, second chapter slide. You tell me once again, recall yourself, what are the laws available? First of all, coupling laws. First of all, coupling laws. From source to fiber end one. That's called coupling law. Next loss is when the light is entered into the cladding, that is called loss. Third loss is fiber to fiber joint. If you want to join one fiber with other fiber, that is called fiber to fiber joint. That may be with connectors, loss, or maybe splices within the fiber if any damage occurs. That is called splicing. You want to weld it, weld the two fibers. If you weld the two fibers, that is called loss. Another loss is when the fiber is going to bend, when the fiber is going to bend, the light is radiated. That is called radiation losses. Radiation losses. Another loss is at the end of the receiver, we have some receiving losses. Maybe that is called uh, that is called radiation losses. Radiation losses. So like this, you have to focus on this losses. It is because that question is very important for examination purpose generally. Okay. Second chapter. Coming to the second chapter of Foley, fiber optics and laser instrumentation. The first concept is light sources. Light sources. Before going to the light sources, you think once again what is optical fiber communication? What is optical fiber communication? Any optical fiber communication will be uh, will be established by with the help of transmitter, receiver, and in between a medium, nothing but optical fiber. Remember once again, transmission section and receiving section, in between a medium, nothing but optical fiber. So what are available in the transmission section? In the transmission section, generally the important devices are light sources. Light sources. And in the receiving section, the important devices are light detectors. Light detectors, also called photo detectors. Okay, and in between transmitter and receiver, there is a medium, nothing but optical fiber. Optical fiber. So this is the optical fiber communication setup. So if you open the transmission section, you can see light sources. What is a light source? The main aim of the light source is it will emit the light. That's all. It will emit the light. How the light is going to emit? If you do any input, if you do any electrical input, by converting the electrical input, it will emit the light. So, what are the devices available for converting the electrical signals into light signals? There are two devices are available. The first device is LED. Second device is laser. LED means light emitting diodes. Laser means, simply you can call it as a laser diode. A laser diode. So these are the two devices are available in the transmission section. So what is the basic principle of the LED, or what do you mean by LED? LED is nothing but is a semiconductor diode. First of all, it is a semiconductor diode. So how do recall once again in the first year EDC or in the physics you may study all these basic concepts. No need to waste our time again once again. But recall once again what is a semiconductor diode. How do you form a semiconductor diode? The semiconductor diode can be constructed by taking two semiconductor layers. Semiconductor layers. For example, you take N layer and P layer, join the two, join the two. The joining point is nothing but junction, that is called P-N junction. Why it remains P? Majority are the holes. Why it is N? Majority are the electrons. So, uh, so in this Pn means in the P layer the majority of the holes, in the N layer majority of the electrons. So if you join this, you can form P-N junction. Fine. We know how to form a P-N junction is very simple. But what is the exact principle and how the light is going to imitate with this P-N junction? If you bias the P-N junction, properly, you can observe the light. So for a P-N junction, you take a battery, P layer is connected to battery positive terminal and the N layer is connected to battery negative terminal. That is called P-N junction bias. Strictly speaking, it is forward bias. Forward bias. Okay, a P-N junction is forward bias. What happens? What happens? The P electrons will cross this and holes will move like this. There is a the junction is going to be crossed like this. Electrons will enter into P layer, holes will enter into N layer. So that is called exchanging all this, exchanging of holes and electrons through this junction. Then what happens? When electrons and holes are moving in the opposite direction, what happens? The forward direction, what happens? When the electrons and holes are moving like this, recombination takes place. My dear students, remember, recombination takes place. Electrons and holes will recombine each other. Electrons and holes will recombine each other. What happens? When the electron will recombine with hole or hole will recombine with electron, what happens? Nothing happens. They simply disappear. Hole and electron, when they are recombined, simply disappear. How do you experience the holes and electrons will disappear? At the junction, you touch your finger, you can observe a light heat, very light heat, you can observe. The light heat, you can observe. So you can observe more heat based upon the compositions we are selecting for P and N. If you select different compositions, you can observe more heat. But based on the compositions, the light heat is observed. Light heat, when the diode is heating means, the meaning of this is recombination takes place because of forward bias. Light, that heat is emitted. Heat is emitted. When the diode is forward bias, recombination takes place. Heat is emitted in the general P-N junction forward bias. The same principle is also be applied for the laser, for the LEDs. You take LEDs, P-N junction, extension nothing but LED. In the LED, what happens? In the LED, you can take different compositions. For N and P, take different compositions like indium arsenic gallium, gallium arsenide. Like this, you select different compositions. So the material compositions are different. Doping is different. What is doping? Adding impurities to N and P. If you add the impurities to the N and P, Thereby we are selecting different compositions. N is different, P is different, compositions are different. Then what happens? It constitutes a PN junction, no doubt. For different compositions, PN junction, now apply forward bias, what happens? If you apply forward bias, again recombination takes place. Now we can observe not heat, we can observe light as output. Light as output. What is the basic difference between simple PN junction diode and LED? In the simple PN junction diode, you are selecting simple compositions for N and P. So recombination takes place. Heat is output. Heat is emitted because of recombination. But in LED, we are taking different composition for P and N. So recombination takes place. Light is emitted as output. So as an engineer, as an instrumentation engineer, if you want to construct any LED, you take the compositions required such that how much light you want as emission. ఎంత లైట్ నీకు ఎమిషన్ కావాలా అనేది నువ్వు తీసుకున్నటువంటి కాంపోజిషన్ బట్టి డిపెండ్ అవుతుంది. అలా సెలెక్ట్ చేసుకోవాలి. అండర్స్టాండ్ మై పాయింట్? యూ సెలెక్ట్ అకార్డింగ్లీ హౌ మచ్ లైట్ able to emit with this composition. So that is called LED. So LED is nothing but PN junction. Is a PN junction but with a different composition, so that if you apply forward bias, recombination takes place, then light is output. Light is emitted. Light is emitted. Remember, my point is, in the transmitter side, the first device is LED. Or sometimes you can use laser. You can use laser. See, this is called laser. See, the first diagram shows that second diagram shows that LED. The light is emitted. Fine. See, when come to the case of laser is not like this. Laser diode, also called LASER. Laser means light amplification by stimulated emission of radiation. Light amplification by stimulated emission of radiation. So in the laser also, what is the output? Light is output. How light is emitted? How light is emitted? Is the process of stimulated amplification and stimulated. With these two processes, light is emitted. See, we know the theory regarding this pumping and pumping process, right? Generally in this lasing action, that is called lasing action. In the lasing action, what happens? When any light will fall on the low energy states, they are excited into high energy states. The high energy states are simply they are unstable states. They will come to down by emitting some radiation. It is we are treating as LED. But this some of the photons available, some of the carriers are available in the high energy state. So if you apply external energy electrical input to the external for the higher energy state, they will come down forcibly. Such that maximum light is emitted. That's called stimulation. Automatically, which is spontaneous. By applying electrical energy, we are pushing the carriers towards down, so that light is emitted. That process is called stimulation. So laser diodes functioning based on stimulation process. So if you, due to this pumping process, if you create more carriers in the higher energy states, you may get more that's called more photons. I mean more light. More light depends upon more carriers in the higher energy states. How do you create How do you create more carriers in the high energy state? Because of pumping process. Pumping process. So the lasing reaction depends upon with the help of applied electrical signal, we are pushing all these carriers towards the so that there is output is like this. Output is photons, light output. That is called H nu. H nu as output. It is another process, laser reaction process. We'll see in the third chapter completely about laser diode types and all the functioning types of layers, all this. Right? There we will discuss. Remember, in the transmitter side, there are two light sources, LED and laser. These two, if required, you can take LED for your purpose, communication purpose, or laser for your communication purpose, or any measuring purpose. Choose only one, not two at a time. Choose LED or laser, only one at a time. Generally, for your distribution purpose, I am speaking, laser is better option. Laser is a better option. Okay. Uh, uh, shall we stop now? Shall we stop now? Okay. At the end, at the end, at the end, we have receiver section. Receiver section we have again. If you open the receiver, there is light detectors. Light detectors are also called photo detectors. Photo detectors. As per your syllabus, we have peak detector and APD, avalanche photo detector. The two detectors are available. The main function of the photo detectors are once the light is coupled from the light source to the fiber, the light is propagated through the fiber. The light is simply propagated to the core of the fiber. Fine. At the end of the fiber, the light is emitted. The light is emitted and fall on the photodetector. The light will fall on the photodetector. When the light will fall on the pin diode or APD diode, the light is simply converted into electrical signal. Electrical signal. So initially what happens in the transmitter side, the electrical signal converted into light with the help of LED and laser. So light is propagated through the fiber. Fine. At the end of the fiber, light is emitted and fall on the optical detectors. So when the light will fall on detector, the light will convert feedback converted into again light signal. Electrical signal. So who can convert the photons light into electrical signals? With the help of light detectors, photo detectors like PIN or APD. Right? We will see all these in the next class. If you have any doubts, you can ask me, you can call me or mail me or WhatsApp me, right? Please clarify your doubts. Tomorrow we will see other class. Okay?